Hello, ninth class students. Previously, atoms and molecules was a separate chapter. What is inside an atom was a separate chapter, and chemical reactions and equations was a separate chapter. But now, these atoms and molecules chapter has been combined with chemical equations. Okay. So, in previous videos, we have covered atoms and molecules and the chapter what is inside an atom. Now, I am going to teach you the chemical equations and reactions separately. Okay, so for that, first I'll be giving you the digital videos, then it is followed by my explanation, so that you can understand or just at least be familiar with the visuals which you see in the video, so that my explanation will be easy for you to grasp. Okay, students, so watch these videos and try to save these videos in your pen drives, whatever digital content I am giving. For explanation part, anyhow I am there, you can use the Zoom sessions which are available with our classes.
Hello friends, this video on chemical reactions and equations part 7 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 6. A good number of exercise for that. Let's see the type of chemical reactions actually. So typically there are 5 types of chemical reaction. The first is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and combustion reaction. There are 5 kind of chemical reactions we have. There are other types also, but they fall in this type. For example, I'll tell you, typically any chemical equation you can see, by looking at the equation you can say that this is one of the type. Correct? But there are other types of chemical reactions also, that is based on the property. Redox reaction is whether oxidation is going on or reduction is going on. We'll explain this. Acid base reaction, that is whether the reaction is between acid and base. Acid and metal reaction. Exothermic, endothermic, that is whether the reaction is giving out heat or we have to provide heat for the reaction. Precipitation reaction, whether you get precipitations from that reaction. Catalysis reaction, whether catalysis is required or not. Biochemical reactions, organic chemistry reactions, photochemical reactions, solid state reactions, corrosion reaction, ratification reaction. There's so many reactions type, but all of these reactions type will fall into that 5 reactions which I have explained, right? So we'll go through all these kind of reactions. We'll see that all these reactions, right, redox reactions, it can be exothermic redox reactions, it can be any of these, displacement or combination. The five basic types which we talked about in the previous slides. These reactions can be any of those reactions. So basically what I'm trying to say that given any chemical equation or given chemical reaction, it has to be one of those 5 types which we have discussed in the previous slides. So let's discuss those 5 types. The first is the combination reaction. The combination reaction. Before I go for the combination reaction, let me go to the analogy of combination reactions. So the general form of combination reaction is you have 2 chemical A and B. It combines to form chemical AB, and there may be some thing required. For example, heat is required or something. External thing is required, right? Extra condition. But general logic is you have 2 chemicals that combines or synthesize to form AB. So the analogy is there's one guy, there's another guy. There are 2 guys, you can say A and B. Now they both like chemistry subject, and if you see that, they become best buddies. So this is one compound. So there was 2 compound A and B. There were 2 students A and B, and they become one identity. That is, they became best buddies, right? So there was one compound A, one compound B, if you see, and they became best buddies because of the chemistry subject, right? So if you see, there were 2 things and that became one thing. That is the example of synthesis or combination reaction. Sometimes you need external factor. For example, chemistry subject is one external factor we have that made these guys best buddies. Sometimes even that is not required. They just become best buddies. So in the form of chemistry, again, we'll touch upon this definition of the same reaction, combination and chemical reaction. We'll see this concept from a chemistry lens. So we have 2 elements that becomes combines to becomes AB. So the description is two chemical species combine to become a single compound, right? So we have two chemical species they become a single compound. That is example of a combination reaction. For example, you have a quicklime and you add water to it, it becomes quicklime. So if you see, there are two elements here. One was a quicklime, one was the water, and it combined to become a quicklime. That is, CaO was my quicklime, the solid. You give water to it, it becomes COOH2 plus aqueous. And if you see, this guy gives heat also, right? It gives heat. So this is an exothermic reaction. So this is one of the reactions which you'll learn now, I mean, after some 10-20 slides. But what I'm trying to say is that this reaction is also another type of reaction also. For example, this chemical reaction, this synthesis or combination reaction can be a reaction also. So we have hydrogen plus oxygen. You combine these two molecules, you get water. So you have hydrogen gas, oxygen gas. You combine this, you get water. So you have two products, you get one product. So we have sodium and chlorine. You add these two, you get sodium chloride. So you have sodium and chlorine. One was sodium was solid, chlorine was gas. You get NaCl, that is again solid. So you have magnesium and oxygen. You add these two, you get magnesium oxide. This we have done actually. So you heat this, so you have this magnesium ribbon. So you heat this in presence of oxygen, you get magnesium oxide. This is also one combination reaction. We have two elements combined to get a single element. You have carbon monoxide and you have oxygen. You again heat this guy, right? So you get carbon dioxide. So that's again a combination reaction because you have two products and you got a single product as an output. So one more example, you have sulfur dioxide and oxygen. You combine these two, you get sulfur dioxide and oxygen, you get SO3, that is a gas. So these are some examples of the chemical reaction which are combination chemical reactions or synthesis chemical reaction. The point here is that in all these reactions we have two products, you get one product out. We have two products, one output. Two products, you get one output. You have two inputs, you get one output. So the reactant part has two items and the product part has one item. That's the example of synthesis chemical reaction. Let's do an activity for that. So what I can do is we can take some amount of calcium oxide or quicklime in a beaker. So this is a beaker and we have taken some lime in this. Slowly add some water to it. Let's add some water. If you see, right, this thing got dissolved. This thing got dissolved, right? So if you see, the moment we add water, this thing got dissolved. And now let's touch the beaker. And what you will notice that it's hot. This is hot. So what has happened here? So we have this CaO, the lime we have, quicklime. On this we added water. This gave aqueous solution. This is aqueous solution actually with the CaO, and it gave heat also. So if you see, two items became one item, right? And this is an example of my synthesis chemical reaction. Correct? So where we have two inputs, A and B, it gives you a new output called A. One product. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on chemical reactions and equations part 8 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 7. The next is decomposition reaction. Let's study the analogy of this. So they were two best buddies, now they're just one identity and two best buddies, and they fought over some topic. I don't know, maybe they got less, one got less marks, something. They just fought, and now they are two different people. So they were one identity called best buddies. They fought in the real life, right? They fought and they became two different identities. This is similar to what we have a decomposition chemical reaction in the chemistry world. So we have this one compound AB. You decompose to becomes two compound. So the description says a single compound decomposes to become two or more chemical species. It may be more also. It can be C and D also. The concept here is one compound and then breaks into multiple compounds. So For example, you have water, you pass some electricity to that, and that becomes hydrogen and oxygen. So on electrolysis, so this is, I think, electrolysis, this water as a wind compound breaks into two smaller compounds. This hydrogen peroxide again, that is converted to hydrogen water when you pass something. We have copper carbonate, they can heat, I think you heat this guy, it becomes copper oxide and carbon dioxide. You have ammonia, you can convert this to nitrogen and hydrogen. So one compound into two small compounds. So you have nitrogen triide, you can convert into nitrogen and iodine. So these are the chemical reactions where you see the common thing is you have one big compound and this got combined into smaller species. This is an example of decomposition of chemical reaction. Correct. For activity, what we can do is we can take 2 grams of ferrous sulfate crystals in a dry boiling tube. This guy is a boiling tube. Here I have ferrous sulfate, right? 2 grams. We'll note the color is blue. Now heat this over a burner. So let's heat this over a burner. But we'll observe that this color changes to red, right? So we'll observe that the color change to red. Also we'll see the pungent smell. The smell comes out, right? It's the nose we have. Smell comes out. There are 2 things. One thing is the color change and you get the smell. So if you see, this was my original compound and this is my new compound, right? This is my new, this is my old compound. So what do you see? What happened here? This guy was my ferrous sulfate. This is in the blue one. When we heated this guy converted to Fe2O3. You got this gas also, and this gas is nothing but a pungent gas which you got. So in this, if you see, one compound is converted to multiple small compounds. This is a typical example of a decomposition chemical reaction where bigger compound is decomposed into smaller compounds. We'll take a more activity. So we take some 2 grams of silver chloride. This is a silver chloride. And we'll note the color. We'll put this in the sun for some time. So we'll have a stopwatch. Maybe after 1 hour we see that. We see that the color changes. It was white, it became gray, right? So let's see the color changes. Why the color changed? Because if you see now, earlier it was AgCl, silver chloride. On sunlight, this broke into silver and chlorine. This is the silver now, and we got chlorine gas. The gas evaporated. So if you see, this compound broke into 2 smaller compounds. And this is also one example of decomposition. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on chemical reactions and equations part 9 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 8. Now we'll see the analogy of displacement reaction, the scenario which we have in real life, which is almost similar to displacement chemical reaction in real life. So there we have one compound AB. Another compound C comes and it displaces this B and the B comes out. That's how it is. There's a compound AB, they're happy together. One guy comes C and C displaces this guy because A is attracted more toward B, or something happens, right? You apply some heat to something, so this becomes AC plus B. For example, in the real life, let this guy be A who is dancing happily with his partner and the partner is B. Right? So they're happily dancing. Now the instructor sees one more girl come and she's also a good dancer. Now the instructor sings, but nothing happens, right? So they are happily dancing, one more person C has come, the person C has come, but nothing happens. Or maybe the moment the person has come, this thing got displayed. Or the external factor is required. The external factor is supposed to be instructor. Instructor says that, dude, this lady is wearing a red dress and you are wearing a blue. It won't look good in the stage. So why don't you swap? Why don't you swap? So then what happens is this lady swaps with this girl and this girl comes out here. So if you see now, earlier A and B were dancing together. There's one new girl who came in C. The instructor told that the dress looks better, the blue and blue. So why don't we dance together? So now if you see, this guy is A and C. Now A and C are dancing, and the B lady who was here, now B lady is out. Right? It may be that A likes to dance with C. It may happen that you don't even need instructor here. The moment C comes, B tells no, I don't want. A tells to B, I don't want to dance with you because you're wearing a red dress. I want to dance with C. Maybe this guy himself tells, because maybe that this guy is inclined toward this lady, or maybe this guy is not inclined that much, but the instructor forced him to do it. So maybe this reaction happens on its own, or maybe happen on some external force, for example, heat or temperature, or temperature or pressure or something, or some catalyst also, right? So some catalyst also may be required for this. So, but end of the day, you forget this part, you exclude this part to make it life simple. But end of the day, what's happening is A and B were dancing, C came, and now A and C are dancing, and the B is gone, right? So this person C took the place of B, and the B is out now. Correct? This may happen in the real life scenario when you're practicing dance in the schools, and the teacher tells that no, this pair doesn't look good, let's change the pair, right? So that's one example of a displacement chemical reaction in our daily life. So let's see the chemistry definition of this displacement chemical reaction. You have this product AB. When C comes, C displaces this guy B, so it becomes AC, and the B is out. So it says that one element or ions moves out of one compound and into another. One example is active acid plus active metals. You get this kind of reaction. This is one example of that. So we'll take more examples. So you have hydrochloric acid and magnesium. If you add, so you have hydrochloric acid and magnesium. What you get is MgCl to an H2. So what you have seen this Mg, it came here and it paired with Cl, and hydrogen is kicked out. Correct? Sulfuric acid plus iron is equal to iron sulfur plus hydrogen. So here if you see, iron came here, it kicked out hydrogen, and hydrogen is an independent identity now. Correct? Fe kicked out hydrogen and it become FeSO4. Here if you see, nitric acid plus magnesium, nitrogen, hydrogen. So we have nitric acid HNO3 plus magnesium, it gives magnesium, nitrogen, and hydrogen. So if you see, the magnesium came here, kicked out hydrogen, and the hydrogen is out, right? And magnesium and nitrate become magnesium nitrate. Zinc you add with hydrochloric acid, this becomes zinc, chlorine, and hydrogen. Zinc and hydrochloric acid, if you see, the zinc guy overtake this guy HCl, hydrogen is kicked out, and this guy is out. So in this, if you see, this happened because zinc wants to gel up with chlorine more, right, than hydrogen. So zinc has a more affinity to gel up with chlorine than hydrogen, and then it pairs, creates a bond with chlorine, and the hydrogen is kicked out. So we'll understand all these things, I think, in the class 11 when we discuss the atoms, the shape of atoms, and how they have neutrons, protons, and electrons, and what makes it stable, and why this reaction happens, right? So all these things we'll study in class 11, the reason behind this reaction, why it's happening. You must be wondering, right? But when you add zinc and hydrochloric acid, why it becomes reactant? This answer to this, but now it will be too difficult for you guys to understand, because in class 10th now, once you move to class 11th, we'll understand why this thing happens, because zinc has more affinity to attach with chlorine than hydrogen. So that's the reason why it happens, right? So we'll learn all the things in class 11, but just for now you can understand that this is a kind of displacement chemical reaction where one element displaces another. So here also lead plus sulfuric acid becomes lead plus sulfate plus hydrogen. This guy lead kicked out hydrogen, and hydrogen is out now, and this becomes lead sulfate. So this is one example of displacement chemical reaction, right? So for this we'll do an activity. So we'll take 2 iron nail and 2 test tubes marked A and B, and in each test tube take 10 ml of copper sulfate solution. So we have 2 iron, 2 test tubes, right? And this is going to be A and B, and both has copper sulfate solution. Immerse 1 nail in copper sulfate solution for in test tube B for 20 minutes. So in test tube B will immerse this nail. In test tube A won't immerse. And will this keep for this 20 minutes. And after 20 minutes, it would take out this nail from this test tube B, right? Please note, test tube A we are not even touching, that's just for show. We'll compare this later. Test tube B is something which we are doing stuffs now. So test tube B we have put this for 20 minutes. It's all copper sulfate solution, right? Now after 20 minutes, take out this guy nail. So we'll see that after 20 minutes the color change. The color of copper sulfate also change and the color of nail also change. And we'll take out this guy after 20 minutes. Now compare the intensity of the blue color of copper sulfate solution. If you see, this guy is dark now and this guy is light. Both are copper sulfate, but this guy become lighter. And also if you see if you compare the nails also, they are different. There's more blackish now, right? So both has changed. The nail color has changed and the copper sulfate solution has changed. What has happened? What has happened is you had this iron that is the nail. In this you dipped with copper. You dipped this guy in copper sulfate solution. What you got is FeSO4. So now this guy is FeSO4, right? And this guy is a little copperish. This is not black actually. This guy should be a little copperish color. So this guy is a copper. This guy is a copper. This guy got a layer of copper here, right? So this guy is a copperish color, and this should not black. There's some issue with the animation. This guy should be a little copperish color, and this guy becomes a lighter color because FeSO4 is lighter and CuSO4 is darker. So that's how it happened. This CuSO4 become FeSO4 and this iron got a layer of copper. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on chemical reactions and equations part 10 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 9. Now we'll understand analogy of double displacement chemical reaction. So till now we have done 3. This is the 4th kind of chemical reaction, double displacement reaction. So here there are 2 pairs, AB and CD, and they swap the pairs. So this becomes AC and this becomes BD. So we'll see how it is. So for example, this is one guy and one girl, and this is one guy and one girl. If you see, this is A is a girl in red, B is a guy in blue, C is a girl in blue, and D is a guy in red. And they want to create a dance pair. They say that I am one dance pair 1 and I am pair 2. They are 2 dance pair, right? So they are 2 elements actually. They are 2 elements. They are together. This is one dance pair and this guy is one dance pair. Now again the instructor came and told that no man, it doesn't look good. Red should pair with red and blue should pair with blue. So now they are like this. Now if you see, this guy was A and the red guy was D, right? The blue guy was B and the blue lady, sorry, this is C, and blue lady was C. So if you see now, from AB plus CD it becomes AD and BC. You see, right? They swapped actually, right? They swapped. So it was AB and was CD. They swapped. It can be any swap. This is swapped. And these kind of reactions are called double displacement chemical reaction. So here I wrote AC and BD. I could have also written AD plus BC. Doesn't matter because anyway we are going for a swap, right? So in this case it is AD and BC. It swapped. It swapped. The condition called instructor. This is something that happens in real life, right? So we form pair and then our dance teacher says, no, this pair doesn't look good, let's swap, and we swap our partners. So that's one example of a double displacement chemical reaction where both are swapped, not only one. So let's understand the double displacement reaction from a chemistry perspective. The formula still holds same. AB plus CD is equal to AC plus BD, or it can be other way around. It can be AD plus BC, that this guy pairs and this guy pairs, right? So any of this is fine. So here the exchange of ion happens. An example is precipitation acid-base reaction. So I'll explain what are these reactions later. So some examples are, if you have this HCl hydrochloric acid and sodium hydroxide, you add this, becomes sodium chloride, NaCl, and water. So if you see this guy H forms pair with OH, right? HOH, and Cal and Na forms a pair, NaCl. So the one in square forms a pair and the one in circle forms a pair. Here also if you see Ag and Cl, both are in circle, they form a pair, AgCl, and the one are in square, that forms a pair, NaNO3. If you see, they form a pair, NaNO3, and this is circle, right? Similarly, we have this BaOH2 and this CuCNS. This becomes, you see, Ba and CNS forms a pair, and Cu and OH forms a pair, right? So this guy and OH2 forms a pair. So you get this kind of equations. Here FeS and HCl. So if you see there, in this case, Fe and Cl forms a pair, and H and S forms a pair. So that's what you get. So this is the example where you have double displacement things happening, right? So hope you understand the concept of double displacement, that both the things are displaced. We'll take some activity for this. We'll take 3 ml of sodium sulfate solution test tube, and another test tube will take 3 ml of barium chloride solution. We'll mix both. So we have, in this case, we have sodium sulfate, and in this case we have, in this case, Na2SO4, and barium chloride we have in this. So we'll mix both and we'll observe that this guy gets a precipitation of sodium chloride. You see this white color thing, right? That guy is nothing but NaCl. So you get a precipitation of NaCl, sodium chloride, and this blue color, what you get is nothing but BaSO4 solution. So when you mix this, you got some precipitation and you got this solution also. And this is the reaction that happens. Na2SO4 plus BaCl2 gives BaSO4 plus NaCl. In this case, if you see sodium and chlorine, they form a pair, correct? They got NaCl. And the sulfate and barium form a pair, it got barium sulfate. And that's what happened. So this is one of the activity to observe this double displacement chemical reaction. Now we'll discuss the last type of reaction called combustion reaction. So anything you burn, actually, there's nothing but combustion reactions. You have your diesel, you burn your diesel, you have some food, you burn it, you have wood, you burn it. Those kind of reactions when you burn something, that is nothing but a combustion reaction actually. So if you see, the thing that happened is you burn something, you have some eggs, you burn that, you get some carbon dioxide and water. This is a typical example of a combustion reaction. Burn anything, you get stuff, that is combustion reaction. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on chemical reactions and equations part 11 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 10. Now we'll discuss the other types of chemical reactions which we have taught, and please remember that these type of chemical reactions will be part of those 5 major types, right? So there are the 5 major types, but these will also be, these are just the reaction based on the property. So other reactions which we have was based on the number of inputs and outputs. For example, in one case, the decomposition happens, right? So one item got into 2 items. In synthesis, we have 2 items, you make it AB, right? So this was the decomposition, this was synthesis, and then you have this displacement reaction. You have AB, you added C, this becomes AC and B. Then you had this double displacement reaction. You have AB and CD, this becomes AC and BD, right? So those, and then you have combustion reactions. So these were the reactions which in the major classification. These precipitation reaction is nothing but a reaction where you have 2 solutions, you mix, you get a precipitation of insoluble C also, and a solution D. So generally in maximum case, this precipitation reaction is nothing but a double displacement reaction. It's a type of double displacement reaction. In 99% case, this precipitation reaction is nothing but an example of double displacement reaction. So you have two solutions, you mix, you get one insoluble substance, that is nothing but a precipitation of that in one solution. Correct? So that's what the chemistry description says. In this precipitation reaction, two solutions are mixed together. It forms an insoluble solid, and that is nothing but the precipitate. It's a type of double displacement reaction itself. So when I'm discussing about precipitations, let's discuss solubility also, because they are all linked together. So things can be soluble, it can be moderately soluble, and it can be insoluble, right? So for example, so if you mix milk and water, they are soluble, right? You can't separate them. Moderately soluble, that you have some sodium chloride and you mix with water, they are soluble, but after some time, if you you'll still find some crystals of that. If you sugar, if you add with water, right, you'll still find some crystals of sugar. Or if you have this chocolate coffee, you add with you make chocolate shake, right? So chocolate shake, you make chocolate and you add with milk. When you prepare the chocolate shake, things looks fine, but after some time, right, this precipitate down. They're moderately soluble. Insoluble is it won't even mix. For example, you take iron nails and you try to mix with water. It won't even mix. You do anything, it won't even mix. Those things are insoluble. And these things are nothing but the property of the substance, right? So the solubility is nothing but the physical property of the substance, and that depends on a lot of factors, how it is structured, and those kind of stuffs will study later classes. These scientists have observed a lot of things, and they have come to some generalization rules about the solubility of certain substance. The thing they observed was solubility also depends on the temperature. In most of the cases, solubility increases with temperature. If you see, if you add sugar to water, you see that sometimes it is not, you're not able to mix it. But if you warm it, you see that you're able to mix it properly, right? This is the real scenario. In your kitchen also you can do this. So you mix some sugar with water, you'll see that you need to churn it properly, right? You need to put some effort to mix it. But the moment you warm it, everything is mixed. So in warm water, things get soluble easily. Same thing with you have this Horlicks in the Complan you mix in cold water, is not that easy to mix, but the water is warm, it's easy to mix. So the solubility depends on temperature in general case. It increases with the temperature. For example, so when you talk about solubility, you don't talk only about the substance, because it depends on the substance, but you also talk about the temperature. So you say potassium nitrate has a solubility of 31.2 gram per 100 gram of water at 20 degrees Celsius. That means if the water is 20 degrees Celsius, you can mix completely this 31.2 gram of potassium nitrate in 100 gram of water. Thus, you can say that solubility depends on two factors. One is the property of the substance, and then it is depending on temperature as well. So a solution that contains maximum amount of dissolved solid is called saturated. For example, if I take 100 gram of water and I dissolve this much gram of potassium nitrate, I call this guy as a saturated thing. But now what happens is, if this is saturated now, and I cool it, I make it, let's suppose, 5 degrees Celsius. Now at 5 degrees Celsius, this guy can hold, let's suppose, 25 grams only, right? Now what happens is, the extra 6.2 grams, it will come out. It will come out, and that will be a solid. And this process is nothing called recrystallization or precipitation also, you can see, right? So that is nothing but we are looking for, right? So we have a solution which has some crystals and they are saturated. Now you decrease the temperature of this, so whatever, since you decrease the temperature, this water can't hold those many crystals, those things will come out, and that is nothing but recrystallization. So all things are linked actually: precipitation, recrystallization, solubility. So I thought it's better to have a slide on this, and you guys should understand what is happening. The real reason behind everything is that a substance can hold a certain amount of salt at a certain temperature. The more you reduce the temperature, this thing comes out, right? So the extra gram of salt which it can't hold, it can't bear, it is crystallized and comes out. And that is nothing but the process of crystallization. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends. This video on chemical reactions and equations part 12 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 11. Now we'll discuss the acid-base reactions, another type of reactions, acid-base reactions. And please note this also will come in one of the 5, the basic properties, the basic classification of the chemical reaction. It will come in one of those 5 depending on the reaction I'm talking about. So general form is acid plus base is equal to salt plus water. So since it is acid plus base is equal to salt plus water, so it is like, reactants of a base and the acids, they react and the product is salt and water, right? So the positive ion of hydrogen of the acid and the negative of this hydroxyl ions, they lose electrical charge and becomes covalent molecular with the water. So you don't understand this line, you can forget this line now. You'll understand this more when you learn the covalent bond thing. Just understand in acid base what happened is you have this reactants of the acids and base and the product is salt and water. And generally it is a double displacement reaction. Generally in case it's a double displacement reaction. And so acid base reaction actually is nothing but a neutralization reaction, because what you're doing is you have a acid, you have a base, and finally you're getting the solid is neutral, right? So it is also called a neutralization reaction. Both are same. You tell acid base reaction, your neutralization reaction, both are same actually. For example, I'll take one example. You have hydrochloric acid as the acid, plus you take a base and AOH. You know that base has OH, and if you don't know, next chapter we are going to, next chapter will go for its acid and base. So you have acid and base, you react, you get NaCl, there's a salt plus water. This is a typical acid base reaction, and if you see here, the chlorine is pairing up with Na to get NaCl, and H is pairing with OH to get water, right? H2O. Water is H2O. This is a typical double displacement reaction where you have acid and base, they combine to form a salt, and also called a neutralization reaction. Now we'll talk about exothermic and endothermic reaction. So it all depends on the heat. So if it gives out heat, it's exothermic. If it takes hits, it's a endothermic reaction, right? So if heat is given out, it is exothermic, and if the heat is absorbed, right, and it is absorbed, it is an endothermic. So for example, so we have this magnesium and we have oxygen, you heat it, right? You heat it, so you get magnesium oxide. So in this case, the heat was required, right? So it is a endothermic reaction. But if you see a reaction, combustion reaction, for example, you have any substance, or you have this lime water, you have COO, you add with water or carbon dioxide, I think, right? So you get CaCO3 plus heat, right? So in this case, if you see, this guy is giving out heat, so it's an exothermic reaction. So you can see that this is a different classification altogether. So these also fall in one of these 5. So it may happen that you get a combustion reaction as exothermic. You also may get a synthesis reaction as exothermic. You may get a this kind of decomposition reaction as exothermic. You may also get a replacement or double displacement reaction also as a exothermic reaction. Similarly, the case with endothermic. So this classification is not based on the product numbers and the replacement it makes. This is solely based on the heat. If it emits heat, it is exothermic. If it requires heat, it is endothermic, right? But end of the day, typically it will be part of one of these reactions, and it depends on the equation I'm talking about, right? You can't say that all the exothermic reactions are decomposition reactions or synthesis reaction or double displacement reaction. It can be any of these depending on the equation I'm looking for. But this is a different classification. If it takes heat, exothermic. Sorry, if it takes heat, it's an endothermic. If it emits heat, it's a exothermic reaction. Now the question is, why is respiration considered as exothermic reaction? So in the exothermic reaction, if you see, we have the heat is given out, and we see that in respiration what happened is we have this food, oxygen is taken, with this we get energy and we get heat, right? This is the typical example of the, or typical equation for this respiration. In this case, if you see, the heat is coming out. Since the heat is coming out, this guy is an exothermic reaction. Hope you understand this? Because of respirations, you have this food in presence of oxygen, the body using some catalyst and enzymes, right? So this guy produces energy and heat. It comes out of this reaction. So it's an exothermic reaction. Now we'll understand redox reaction, nothing but oxidation and reduction reaction. It's a very critical reaction. So reaction that involves loss or gain of hydrogen is called redox reaction. So if you are gaining oxygen, gain of oxygen or loss of hydrogen, that is oxidation. You are losing oxygen or gaining hydrogen, that is reduction, right? So you gain oxygen. So if you're gaining oxygen or losing hydrogen, it's oxidation. So oxidation means gain oxygen. Reduction means lose oxygen. Correct? So for example, if you have this copper, you have oxygen, you heat this copper, right? In presence of oxygen, this becomes COO. So in this case, if you see, the copper is gaining oxidation, oxygen. So you can say that copper is oxidized. Again, this copper you again heat in the presence of hydrogen now. So if now again see, the copper is losing electron, losing oxygen. So in this case, you see, the copper is reduced and hydrogen is gaining oxygen now, right? Hydrogen was H2, it becomes H2O. We can say that hydrogen is oxidized. Correct? So anything that gains electron, gains oxygen is oxidized. In this case, copper is oxidized. Here hydrogen was gaining oxygen, hydrogen oxidized. Anything that loses oxygen is called the reduction force. In this case, the copper lost oxygen. Same thing for hydrogen. If something loses hydrogen, that is oxidized. Something gains hydrogen, that is reduced. We'll study all this reaction in the later chapter more in deep. Corrosion is an example of a redox reaction in daily life where this things you see is it gets corroded, right? So it was a good looking object and this thing became rusted. So what happens in corrosion is and the question is, why do you apply paints in iron article? Because we don't want this iron to come in touch with oxygen. So what happens is you have this iron, it comes in oxygen, this gives a reaction, it's called Fe2O3, and that is nothing but rust, which you see here. To avoid this oxygen, we paint this. So if you avoid this oxygen, if you paint this, the iron won't come into contact with oxygen and this Fe2O3 won't be created. And then the resting will be provided. And why this is happening? This is the redox reaction. Why? Because the iron is gaining oxygen. So iron is oxidized here. Correct? So we'll study more in deep about oxidation and reduction in class 11. Just in this chapter, the concept was to make you understand the 5 basic type of reactions we have, right? And other reactions which you generally use, for example, redox reaction, acid-base reactions. One rancification reaction is also one example of redox reaction in real life. So if you see the food which you have, which you keep in some time in dry place, it gets a bad smell. Why a bad smell? Because this guy has fat and oil, right? This thing get oxidized and they become rancid and their taste is very bad. This is one example of redox reaction in real life, right? And that's why what we do is we keep this food in an airtight container, right? And also if you see the chips which you get, the chips, Uncle Chips, and Lay's and all the chips you get. They are packed in this wrapper and they are all airtight. And this inside that they put some nitrogen, so that they don't have they don't come in contact with oxygen, and these prevent these things to get oxidized. Because if it's oxidized, it gets spoiled first. If you see the pickle also we have in homes, right? That is dipped in oil. So this pickles which we have is really dipped in oil. Why? Because in oil, if it is in oil, it won't get contact with oxygen. If you don't get contact with oxygen, it won't get rantified and it won't get spoiled. Right? So that's one way to prevent these things from getting rantified. So what we have learned? We have learned the chemical equation definition, that it represents reactant, product, and the physical state symbolically. And the chemical equation has to be balanced always, right? The law of conservation of mass. So in combination reaction, we have two or more substances to form a single combustion. In decomposition reaction, we have one compound bringing two or more substance. So in displacement reaction, we have one element displace another one. In double displacement, we have both the elements swap, right? And the reaction where heat is given out is called exothermic. The reaction where requires heat is called endothermic, right? This we have learned. We have learned the oxidation is nothing but the process of gaining of oxygen or losing hydrogen, and reduction is the reverse process of losing oxygen or gaining of hydrogen. That's what we have learned. Thank you. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.